characteristics of an index fossil. Now, before we get to what an index fossil is, we need to talk about what correlation is. That's what an index fossil helps us do. Correlation means to match up one thing to another. People do this. People tend to correlate or match up. Here you can see some people that have correlated their outfits or matched up their outfits. Sometimes it's a little scary, but people can correlate or match. You'll notice that one outfit matches the other outfit. Mr. Coyne and Mr. Burke sometimes correlate. This is a picture from them from a couple years ago. There's Mr. Burke and Mr. Coyne back in their younger days, and they would correlate or match up their outfits. In college, I had a professor named Dr. Scatterday, and he was a paleontologist and a paleontological professor. He was involved in finding a mastodon. You can see him pictured here with some mastodon bones that were found down in the Avon area. And one day he says, all right, class, we're going to go on a field trip. And he took us to the Rochester Gorge, which is right here in Rochester. And we would walk down the gorge. And as we walked down the gorge, he had us collect rocks and measure thicknesses. And we made this stratigraphic column to show what all the different layers were. And what you can see here, the dots, remember, said it was sandstone. We wrote in the sort of fossils that we found inside. Here we found a shale layer, and he told us the names of some of them. That was in Rochester. The next class, he says, all right, well, now we're going to switch. Instead of going to Rochester, he brought us over to Niagara Falls area. And in Niagara Falls, we, again, walked down a gorge and looked at the different rock layers. And again, we saw some sandstones and shales and limestones, and we wrote those down. He then asked us to correlate or to match the rock layers up to find out where the rocks in Rochester matched up to the rocks in Niagara. And here's the final finished product when we finished matching or correlating the rock layers. We're going to talk about doing the same thing. How can we match rock layers up from one part of the world to other parts of the world? Well, in our notes, we can see that correlation means to do that, where we find rock layers that are far away, and we're going to try and match them up by comparing their rock types and sequences. So here we've got one area. Maybe this is the area down around Buffalo or Niagara Falls. Then we've got another area, and maybe this is Rochester. And there's a large difference. If we have a gorge or we drill a well, we could see the rocks that are underneath the ground in both areas, but we don't know what's going on in between. Can we try and correlate or match these rock layers up? Let's start with this limestone layer H that we find in this one location. Can you figure out what layer, limestone layer H, matches up with over here? We have a couple options over here. I see that limestone layer H has a limestone pattern. Therefore, it might match up with D, but I also have a limestone here at A. To figure out which one it best matches up with, I'm going to look at the thickness of the layers. H is thinner than D. It's about the same thickness as A. I'm also going to look at the sequences of the rocks. Here I have a shale above rock layer I. D has a gypsum above this one, and E also has a shale above that. So it looks like, or A has a shale above A. It also then has above that shale a sandstone, and above this shale B, there's a sandstone C. So I would guess that H would best fit with A than it would with D. So I'm going to match or correlate those two rock layers by connecting them. So it looks to me like the limestone that I found at this area matches with limestone A over here in this area. And from there, we could actually start correlating or matching up other layers too. I see that this shale correlates nicely there. I have this large sandstone, which correlates nicely there. And then this limestone here, maybe it did exist in this area once, but then was weathered and eroded away and doesn't exist anymore. And then these layers, I'm not really sure what happens with them either. So we have just correlated or matched up rock layers in one area with another area, and we did that looking at the types of rock and the sequence of the rocks. More importantly, is what we find in these rock layers to try and match the rock layers up, and those are fossils. On page 88, we see that we have three, instead of matching up 2 layers, we've got 3 layers to try and correlate or match up. So I've got location number 1 here, location 2 here, and location 3 here. This represents the surface of the Earth, and these are sedimentary rock layers underneath the ground. Let's try and see if we can figure out which rock layers match up to which. Now, we no longer know what the types of the rocks are. The only thing we have to use are these fossils in here. If a fossil is helpful in matching them up from side to side, we say that it is an index fossil. Notice in your notes on page 89, it talks about an index fossil. Index fossils help us correlate rock layers. And it says specifically that index fossils have 2 characteristics. Here they're listed here. They're geographically widespread. Right? Geography is locations, widespread, many, many places. So a index fossil is found in many different locations, but it existed, it lived for a very short time before that critter became extinct. If it lived for a short time, it's only going to be found in very few layers. So index fossils are geographically widespread and they're short-lived. They're found in few layers. So using that information, can we find what is a good index fossil on page 88? So let's take a look at each of these fossils. We've got this shell here. Let's go find where that shell is. There's the shell. It's definitely in location number 1. I find it in those layers there. I also find the shell here in location number 2. And I find that shell here in location number 3. So this shell is geographically widespread. Yes. Is this fossil short-lived? Remember, short-lived means it's found in few layers. No, this fossil is found in every single layer. We don't know if this shell fossil matches up with that one or that one or that one or that one. That doesn't help me match up the layers. I don't know if layer D over here matches up with F or G or H or E. These fossils are not short-lived. So is it a good index fossil? No. Let's take a look at the fish. A green fish. So I've got a fish here. I've got a fish here. There's a fish hanging out. There's a fish hanging out. No fish at location 2, no fish at location 3. So we find that fish in only one location. Remember, good index fossils are geographically widespread. They're found in many locations. This fish, is it geographically widespread? No, it is not geographically widespread. Is it short-lived? Is it found in only one layer? No, it's found in a lot of layers. It's found in layers A, B, C, and D. It's found in young layers and old layers. It's found in both the youngest as well as the oldest layers. It is not short-lived. So the fish as an index fossil? No, it's actually pretty bad. All right, let's move on and check out the starfish. So here's our starfish. We find a starfish here. We find a starfish here. And we find a starfish there. All right, is the starfish geographically widespread? Yeah, it's found at locations 1, 2, and 3. We find it in all of those. So geographically widespread, yes, it is. Is it short-lived? Meaning, is it in just a few layers? Well, yeah, it's only one layer here. It's only in one layer here, and it's only in one layer here. So yes, it is short-lived. Is the starfish a good index fossil? Yes, it is. Starfish is a good index fossil. Let's check out our triangle, which, I don't know, let's say that's a trilobite or something. We've got this triangle fossil. It's not in location 1, not in location 2. It is in location 3 and in just one layer. So it is short-lived, but not geographically widespread. No, not geographically widespread. Short-lived, yes, but it's not a good index fossil. It doesn't help me that it's here in location 3. It's not in these other locations. So how can I possibly match the layers up if I've only got it in one layer? That doesn't make any sense. So no. I don't like that triangle as an index fossil. The starfish is a good index fossil. That's going to help me match these layers up. I know that layer C here matches up with E over here. It's the only place we find a starfish here. This is the only place we find a starfish. It's geographically widespread, but this starfish existed for a very short time. It became extinct. So we only find it in a few layers. From there, I could probably make some guesses as to where the other layers match up. All right, if you look at page 90, you have some practice questions. So question number 1 says, which fossil appears to be the best index fossil? So if we take a look at this critter first, we find it in outcrop 1. It is also found in 2. It's found in outcrops 3 and 4. So it is geographically widespread, but it's only happening, it is happening in 2 layers here. It does happen in 1 here, so it's a short time here, but not a short time in those others. So we could probably find something a little bit better than that one. Let's take a look at this next critter here with this nautilus. I find it here in outcrop 1 in that 1 layer, here in outcrop 2 in that 1 layer, outcrop 3 and 4 also in that 1 layer. That looks like a pretty good index fossil. It's found in all 4 outcrops, so it's geographically widespread. It lived for a very short time. It's not found in these other layers, and that helps me match these layers up or to correlate them. So I know that these match here. If I look at the other choices, I've got this shell fossil that I do find in all of the outcrops 1, 2, 3, and 4. And it looks pretty good because it might help me match these layers here up. But I'm not sure if this matches to that one or to that one or to that one to that one. I don't know where it matches. It didn't live for a short period of time, at least definitely not in outcrop 2. And then this last one here, this Tenticulites, which was a type of coral, it only exists in outcrop 4. It should live for a short time, which is good, but it doesn't exist in these other outcrops. It's not geographically widespread, so that doesn't help us figure out the correct, that doesn't help me correlate the layers. So the best index fossil would be choice B. Let's take a look at number 2. Says which characteristics of a fossil would make it useful as an index fossil. So remember, index fossils have 2 characteristics. They're geographically widespread and they exist for a short time. So I want a narrow time range and wide geographic range. The correct answer 2 is C. And this might seem like a strange time to talk about volcanoes, but when that volcano erupts and all that volcanic ash gets pushed up into the atmosphere, the prevailing winds will blow that ash all over the place. So this volcanic ash acts like a time marker. The same way index fossils are good time markers, volcanic ash is a good time marker as well. So if we take a look at our notes, let's add, we've got index fossils help us correlate. Let's also add volcanic ash. So volcanic ash, when the ash is in the atmosphere and it lands, it's going to spread geographically. So volcanic ash will also spread geographically. And it happens in a short time. So volcanic ash will move and will settle down within a couple days. So volcanic ash is going to happen in a very short time. It will also help us correlate. If we find a layer of volcanic ash in between these rocks, and we also find a layer of volcanic ash down here, it may help us correlate or help us match up those layers.